All right, hello everyone, and welcome to our Gigaom Research Webinar Roundtable on Changing the Game, Leveraging Tools to Build Machine Learning into Applications. Joining us today for this one-hour discussion is Gigaom Head of Research, Tim Crawford, and panelist from ActiveState, Jeff Rouse, Director of Product Management. Before I turn it over, I'd like to mention that we will open the floor for a live Q&A at the end of the presentation. Kindly send your questions throughout the broadcast to the questions panel, and we'll answer as many questions as we can. Now I'll turn the presentation over to Tim Crawford.
Thank you, Peyton, and thanks everyone for joining our webinar today. We have a really interesting topic to discuss around machine learning and applications and tools and the intersection of the three. And when you think of what enterprises and companies are trying to contend with today, they're thinking about how to leverage data, and data is that new gold. And so as we start to amass greater components of data as well as just volumes of data, we need to come up with better ways to be able to manage that, and that's really where machine learning comes into play. And then from there, we need to leverage tools in which to take advantage of machine learning and take advantage of that data. And so today I'm joined by Jeff Rouse from ActiveState to help kind of tease apart some of these pieces and bring some light to where data and machine learning and tools and building applications all come together. So Jeff, thanks for joining today in the conversation.
Great, Tim. I'm looking forward to our conversation. I think it's going to be a lot of fun.
I'm looking forward to it. I'm looking forward to learning a lot from you as well, because I think this is an area that I've spent quite a bit of time on, especially of late, and I get a lot of questions about it, but I'm really interested to hear kind of your perspective. So maybe if you could just take a moment and talk about your role at ActiveState so folks have a healthy background there.
Yeah, absolutely. So personally, I've been in the industry now for going on 25 years. I've worked in a variety of different industries, everything from gaming to energy to finance, and now spending most of my time in the open source space with ActiveState. And ActiveState has been an organization that has been based around open source technologies, and it's been around for 20 years. Many people know of us for Active Perl, where we did a sort of a groundbreaking Windows version back in the day. We continue to do Perl. We also have a product around Tickle. We are also one of the founders of the Python Software Foundation, so we have an active Python distribution as well as a variety of developer tools. And we've also done a bunch of work on in the cloud space. So we had a product called Staccato, which was purchased from us a couple years back by HP. So overall, we have been watching the machine learning space with great interest, and of course that's been driving a lot of demand for Python in particular, and we'll be talking about that today.
Sounds good. And you mentioned something that I'm sure is on the minds of a lot of attendees, which is open source, and where open source fits in when you think about data and ML and tools. So let's start with our first question and kind of take this to the top, and then we'll start to drill into this. And for those attending, I will encourage you, you'll want to stay to the end, because we have something teed up for the end that I think will be really valuable as a takeaway. So let's start with talking about opportunities and challenges. When we think about machine learning, when we think about, when we think about what machine learning is, that's one thing, but how is it that people can really leverage machine learning, Jeff?
Yeah, so that's a good question. So maybe just to give a little bit of background, I want people to realize that machine learning, of course, it's a very hot topic today. But at the end of the day, it's just it's math, it's statistics, it's algorithms, and it's really systems that are the ability to automatically learn and improve without you actually have to be explicitly programming them. So differing from an expert system. So the opportunities today, of course, there's a lot of hype around it, but it's grounded in a lot of very high-value activities. So we see a lot of it in visual recognition, so being able to identify stuff in images, the audio aspect of it, being able to do voice recognition at a very high rate. We've also see it for classifying things in the medical field. And there's a considerable amount of opportunity here for most organizations in most industries, just because we've got a model and we've really got a tool set now that gives us a greater ability to get value out of the data we have as an organization.
And when you talk about data, some of the things that you mentioned there are things that historically have been very challenging for us, right? When you talk about images, and I just saw some examples of this just this week, where images are being broken apart into specific data elements. That's a pretty new space, it seems, and an area where machine learning can really assist. Would that be fair to say?
Absolutely, that's vital. So if you look at how industries are processing data themselves, they used to think of it just as, well, what can I put into a database, sort of what's text, and now it opens up that whole area to images. So even something as simple as, there's things going on in our plant, I get an image of it, I can identify what's going on in that plant. I can identify the logs on the back of a logging truck. I can identify the pictures that are in this security image. There's just so many applications of it now because the image recognition is getting so high. I mean, with that, of course, there are some ethical concerns that organizations have to also deal with, but the technology is there to really push us along.
So do you feel that this is a situation, and I want to touch on the challenges too, so we're not just talking about motherhood and apple pie, and we're not just talking about the conceptual. I want to get into some of the meat and potatoes of it, because I think, as someone who's listening to this webinar, someone who's actually either thinking about ML and how it fits in, or trying to kind of wrap my head around it, I want to know, what are some of those challenges? Can you touch on some of those pieces that are a challenge today?
Sure. So for machine learning, one of the biggest challenges is figuring out where you can get the most value for your organization. So there is an incredible array of tools out there, which we'll get into, different methods and techniques. Typically, the individuals involved have to be highly trained in order to make these decisions. So one of the biggest challenges is putting that all together, on top of the fact that the whole area itself is moving very quickly. So that brings its own set of challenges to organizations.
Yeah, and that's actually something that I'm starting to see, and remarkably, I wasn't expecting this, but in the space of ML and even AI, I'm starting to see the acceleration of the maturity of the space happen much faster than I would have perceived. I don't know if you're seeing something similar.
Yeah, absolutely. Well, you can really see it when you look at voice recognition. So for everyday usages, you can see, like, well, how much better has your voice assistant on your phone become in the last couple of years? How much better has Alexa become? And that's all based on the maturity of those technologies.
Wow. So that's a great segue into our second question. When you're talking about ML, one of the challenges, and you touched on this a little bit, was you have to be an expert in this space to be able to do it. But that seems to be changing pretty quickly too. How do we increase that approachability for folks that want to get into ML, want to be able to leverage ML? What are some of the things that are helping that process along?
Yeah, so that's a great point. So as much as the space is really for machine learning experts, data scientists, it's getting to the point now where you can actually say, well, I've got this problem, and what are the tools and features out there that I can use to solve that problem? So I'll give you an example. So let's say you want voice recognition. I'll just stay on that particular topic. You don't have to be an expert in the machine learning algorithms that are best at voice recognition. You could actually use an API to a service that already has a trained model, that already has scale of data behind it to train that model that you as an organization don't have. So for instance, Amazon has Lex, which is what drives Alexa, for instance. So that's a good example of where you don't have to be a data science expert, yet as a developer, you could still get that capability into your software.
Are there other aspects that come into play from vendors or from the community that would help kind of move things along for folks that are trying to kind of reach into the ML space?
Yeah, I think in particular the communities around a lot of these machine learning technologies, they need to really provide a higher level view of what it is they're doing with these tools. A lot of times it's very low level, it's very technical, and it doesn't have to be that way because there's a set of people who will find that, but there's also a set of people they want to get into that community, they want to use their tools, that they can really just provide a higher level description, and that's some of what we do at ActiveState.
What's the starting point for someone that wants to delve into this? And I don't want folks in the audience to think we're just going to talk about the high level. We're going to dive into the details here in short order. But for someone that's just getting started, what's a good starting point to kind of come up to speed and kind of an early touch point?
Yeah, so there are a variety of good sources on the net around getting a high-level overview of machine learning. Depending upon your level, if you're more of a developer, you may want to take one of the great machine learning courses that are online, like Andrew Ng's course is extremely popular. I think hundreds of thousands of people have taken that. And at a higher level, more for executives, there are some great white papers around. I know we offer one in the Python space to really understand the data science angle. There's some great books about data science and building up those kind of teams. So, you know, there might be it might be best if I provide some of these links as a follow-up to the webinar. Yeah.
No, that'd be great. That'd be great. And I want to make sure that I go back to something just real quick, quick housekeeping pieces. As we go through this conversation, you know, for the attendees, if you do have questions, please use the question dialog box that's in the webinar control panel. And we'll try and get to as many questions as we can as time permits. So, you know, kind of coming back to the starting, and you mentioned about community, and we've touched on tools very, very briefly, but when we think about approachability, are tools the requirement, or is there something else beyond tools? And then we'll kind of delve into the tools next. So what else is there besides tools that one needs to think about?
Right. Well, in machine learning, it's all about your data. So that's probably the key point, is that if you're going to have a successful implementation of machine learning on whatever your problem set happens to be, it really comes down to the data that you have. And we're also going to get into that further on, as well as some of the tools around that. But the data itself is the key here.
So let's maybe just take a quick minute and talk about that. What do you mean by data? Is this more data? Is it different types of data? Is it data hygiene? Is it all of the above? Is it more than that?
Yeah, so it's really all of the above. So machine learning models most machine learning models require a substantial data set in order to train them up. And this is particularly the case for, you know, if you're doing some sort of image recognition or over a large, maybe you've got a lot of medical images you want to go through, so like a radiology data set, for instance. So having that labeled in a format that is consistent so that the algorithms can deal with that data and you get the correct value out of it is very important. So a lot of data scientists will tell you that anywhere between half to 90% of their job is really just all about cleaning the data and getting it prepared to put into these models. So,
yeah.
Sorry, go ahead, Tim. Yeah.
No, go ahead and finish your thought. Sorry.
Sure. So and that is, you know, it's sort of a garbage in, garbage out, no different than anything else we've done, you know, development-wise, is that it's all about having that consistent set of features identified and clean data, clearly labeled data, so that we can actually build our inferences up.
You know, it's one stat that I heard just recently is actually much greater than what you just conveyed, is that 80% of the work that data scientists are doing is cleaning up. And it's not just cleaning up from, I guess hygiene is not the right term to use, but in some cases it's breaking up the data into atomic chunks or into chunks that you can then specifically leverage. So it's part of it is cleaning, right? There is a hygiene component, but there's also kind of a preparatory component that comes into cleaning and organizing the data in a way that you can then apply the model and leverage the model. And so the stat I had heard was that 80% of the work is just all of that preparation that goes into getting your data together and getting things cleaned up before you can actually kind of jump into the model.
Yeah, absolutely, and it's such a big part that even, it really has its own discipline, which is data engineering, which is really, an organization's data and all their data pipelines and all the monitoring around it and the storage of it and the massaging of it, and that's before it gets to really the data science team to really work on the ML model. So it's a key component, no matter how you slice it.
So let's shift gears a little bit. Let's get into some specifics around tools, and this kind of gets us to our next question. What is that relationship between tools and machine learning? We've talked about a lot of the components that go into machine learning, or at least touched upon them, right? Kind of glance across it. We probably could spend an hour just in each of these little veins.
Yeah.
But what are some of the tools and the relationship between tools and machine learning? Where do tools kind of fit into this?
Sure. So, depending upon your definition of tools, it all starts with the languages. So it's really important to have the right foundation in order to do all of this. And by foundation, I mean things that can drive your data engineering, things that can drive your data science, and things that can drive the actual deployment and how you put it into your various applications, whether that could be API-based, kind of a microservices-based, or whether it's more of a monolith, whether it's inside your firewall or it's something you're producing externally. It's a long tool chain, and one of the most important areas in this whole tool chain is the language called Python. It probably has the bulk of the machine learning libraries. It also has the data engineering libraries and some really strong web and API frameworks. And so that's one of the reasons why Python is today continuing to be one of the fastest growing languages and largest languages inside the enterprise.
And I know ActiveState has a long history, as you mentioned, and kind of from my own experience, I was a Perl user as well of ActiveState's products years ago, but let me emphasize the years ago part there.
Yeah.
Where does R fit into this? When we think about languages, and then I also want to shift this a little bit to tools too, but does R fit into that, and how does that relate with Python? Do you tend to see one versus the other used in certain ways?
Yeah, R is very strong. It's very strong amongst the statistician community. It's also got a great set of libraries for machine learning. There's some great interplay between Python and R. There's something called RPy that can be used to talk back and forth between the two. So it's a very strong language, and there's lots of other languages too that play very well in the machine learning space, including Octave. And there's implementations in Java and Scala, and then actually Go. We're seeing a huge emerging data science area as well.
Wow, even in Go.
Yeah,
that's interesting. So again, let me come back to this about the tools a bit more. What is that relationship between the tools? Is there a component that tools have to be part of whatever strategy you're using with regards to machine learning? Do tools become the requirement or the foundation or just the leverage? What is that relationship between the tool and machine learning?
Yeah, so it's pretty much required that you have the proper tooling in order to do machine learning. It's just it's so vast that you really want to pick the right tools for the job, and these, if I pick on the Python space in particular, it's really the tools for the set of machine learning or data engineering you want to do. So if you're doing deep learning, that might be something like TensorFlow, or even Keras at a higher level. And then if you want to do, maybe some more, how would I put it, outside of the neural network area, which is the hottest probably in the space, you would use something more like a scikit-learn, and that'll give you a lot more of like regressions and other anomaly detection and things like that. So.
Okay, so let's kind of delve a little further into that, and that kind of gets us to our next question about tools when you're building machine learning into applications. Where have you found to be the best use of tools? And I want to talk about this over the course of maturity too. So as you start to mature your thinking around machine learning, and maybe for folks that are getting started versus folks that are more mature, do tools fit into the application development process better in certain places as opposed to other places?
I think you're going to find that you need the necessary tooling all the way across. When you're fitting machine learning into applications, what we're really talking about is at the point at which we've trained a model up and we've got something that we want to put in and leverage in our applications, how do we deploy that model? So a lot of that is, again, back to where we store the model. So that can be in a database. It could be, it could just be a file that consists of like protobufs or JSON, and it's really up to the architecture that you're implementing to know how best to do that. You could be accessing it out through some APIs. So the tooling is going to be important, and it's such a vast area. It's tough to just say, well, there's this set of tools that are best for the job. It really depends on the organization's capabilities, their strengths, what their developer strengths are. So it's definitely a broad area.
Okay. And we have a couple of questions that have come in, and I would encourage folks to please submit your questions, and we'll get to them as we go through. I want to cover one of them real quick. It kind of goes back to what we're talking about on the classes. Andrew Ng's class, that's the Stanford class that you're referring to, right?
Yeah,
through
exactly.
The Stanford program?
Yeah, it's actually offered through Coursera.
Okay.
Yeah.
All right, and I know I've had the opportunity to meet Andrew, and I will say, he's a great educator, and so go to Coursera, look for Andrew Ng, A-N-D-R-E-W, last name is N-G. He's a great guy to follow. So then the second question, and this kind of ties to our current conversation, is really around: is there any cookie cutter way of looking at any problem when thinking about machine learning and how to solve it? So I think the question really comes down to, I know I need to leverage machine learning, but is there a way I should be thinking about, or a structure or method I should go through to think about how to leverage machine learning in solving a problem?
Yeah, so that's a great question. So machine learning is really split into a variety of areas that you can then use to tackle a problem. So a lot of it is whether or not you want more of a supervised learning problem, and what I mean by that is, here's a data set, and we know, let's say it's images, we know what's in that image and it's labeled that way, and then we can train up our model based on that, and then we can test it against a bunch of images that we also have labeled, but we can use it as to verify how good our model is. So that's an example of supervised learning. There's also learning around just dealing with how we classify data. So as data comes in, we cluster it in certain areas, more of like a slightly different approach. There's also, we can use models for reinforcement learning, which allows us to get more feedback about what's going on in a particular problem set. So there's a lot of different classes of problems that machine learning can solve, and I mean, it can be clustering, dimensionality reduction, structured prediction, anomaly detection. There's just quite a number. So I encourage people to get introduced to the field so that they know how best to apply it. There's not really a cookie cutter way that, at least that I'm aware of, to say, okay, I've got problem X, what's the exact way to solve it?
Yeah, use this approach, right?
Yeah, exactly.
Yeah.
Use this approach. I mean, there's some general things, like if you're doing image classification, sure. The approaches are pretty straightforward. I shouldn't say straightforward, but well known, right?
Yeah.
But if you're doing something, maybe your data is a little less structured. Maybe you need a different approach that isn't recommended. I mean, that's really where you do need some expert help in order to find the right solution.
But it sounds like the first step is get yourself educated with these different terms. So I think, a great example of this is understand the difference between supervised learning and reinforcement learning. or data classification, right? If you understand what those mean, at least from my own expertise, I would say that's really helpful in informing how I might approach the problem. I mean, would you agree with that?
Yeah, I would totally agree with that. Absolutely.
So that's great. So okay, so let's kind of step into that a little bit further. You know, we touched on tools, but I want to get into this other area where you start talking about not just the tools, but kind of to the question about how to think about these problems and how to solve these problems. You know, and this gets to our next question, number 5, which is, where do workflows, APIs, and algorithms fit in? And I know those are, in some cases, a juxtaposition of different terms when you think of machine learning. But maybe we can just kind of pick apart each of those pieces as the next level of discussion.
Sure. So let's just outline a workflow, a typical workflow. So we've talked about the data. So it's really the data collection, and then you would do the processing on that data. So whatever you need to do in order to prepare it, clean it. And again, this is oversimplified, but I just want to give people a sense of what the workflow looks like. Then once you've got that data in place, then you can actually do the machine learning on it. So you can experiment with your models and tune your models, you know, train them up. And then after that, you get into the point where you can actually deploy it. So build it into your applications and deploy it to get the value out of it. And then out of that, then you're getting the predictions. And then over time, you may want to be retraining that model as new data comes in, and sort of this sort of circle will continue, so that, you know, things don't get stale. So that's a kind of a typical workflow. And then APIs, so how do they fit in? So, and that's really the point at which you're building your models into your application. So you might be leveraging, let's say, some Amazon APIs or Azure APIs. You might be leveraging different open data services. Maybe that is feeding things. So that's where the APIs come in. Or you may be building your application to be an API for services inside your organization or for customer organizations. So the APIs are really a way to leverage the value you have.
And so let me just kind of pause you for a second before we go into algorithms. So when you talk about the workflows, for example, and I want to kind of pick apart these pieces so folks really understand that. When you think about the workflows, this isn't, when we're thinking about machine learning, and correct me if I'm wrong here, but it's not like a typical application where you build it and then you deploy it and it works until you need to make a modification or need to fix a bug or need to make some change. Machine learning functions are alive and in constant motion, and that's where this training and retraining become incredibly important. Would that be fair to say?
Yeah, that's totally fair to say. And again, how often you need to update your model as information's coming in really depends on your problem domain. So I believe, like, if you look at the recommendations engine that Amazon uses, they try and update it about every 6 hours, but they have a massive amount of data and an incredible amount of compute they need in order to do that. But they want to make sure that they're not missing trends in the marketplace. For others, it might be that model, you maybe need to retrain it once a week, maybe once a month. It really depends on the type of data you have and how you're you're servicing your customers, or the type of value that their customers are getting out of it. It really is problem specific.
So, and that kind of leads me to a question I was going to ask in regards to APIs, is that, I mean, again, unlike many applications that are built, especially within enterprises, and when we talk about data, with machine learning, we're not just talking about leveraging data and insights and algorithms and functions within our company, right? You mentioned Azure, you mentioned AWS as examples. Can you talk a little bit about why you would leverage those functions, or why, like image recognition, why you would leverage that? Is it a scale issue? Is it, are there insights that you gain from that?
Yeah, so it's really back to sort of the classic buy versus build scenario that everybody's familiar with. So for instance, I wouldn't necessarily recommend you build your own speech recognition system when there's a Lex out there that you could use that. That might not be a core competency of your organization, but you may want to be building particular specific algorithms for your domain, so that will give you the most either competitive advantage or the best value. So it's really how you want to use it. I mean, gluing together a lot of APIs can give you a quicker ability to get to market, but building something more custom, let's say in Python, could give you a greater competitive advantage. So it's really up to what you're trying to get out of it, and then from there you'll be able to figure out, well, should I be using external APIs or should I be building them myself?
And so I guess one of the things I think about, and I'm tying this back to some of the image viewing and being able to break down the pictures, for example.
Yes.
Companies like Google and Amazon and Microsoft have access to a vast number of images, well beyond what any individual company has. Is this an opportunity to really leverage their expertise and tie into those APIs versus trying to do it yourself?
Yeah, absolutely. So, and that's the nice thing about the programming languages is that you can actually tie in all these great services that are built in some other language through these neutral APIs. So you don't necessarily want to be going through millions and millions of images in order to build up your own recognition system, but you might want to be able to just leverage a light version for an edge device. You might want to be able to leverage a more hardcore version that, say, maybe a Google or a Microsoft is offering up. So there's just a lot of ways you can play this, and it's really up to what you're trying to get out of it.
Okay. I want to go to a couple of questions that have come in, and again, thank you folks for submitting your questions. This is great. Love the interaction. So one is your thoughts on next generation intelligent enterprise apps powered by ML, AI, DL, statistical modeling, etc. For example, Google Maps from a consumer apps that does dynamic route optimization with a simple UI. I mean, this is a pretty complicated space and can be complicated. What are your thoughts around these next generation intelligent enterprise apps?
Yeah, so this is a great space. So again, this is really all about tying APIs together with your own application. It's going to get better and better. Like in the case of these maps, for those of you that do a lot of commuting, I'm sure you've noticed how good Google Maps has gotten over the last, I'd say, probably 5-7 years. I mean, just the ability for them to take in what the traffic is like. I mean, it's almost like a superpower. And these things are going to continue to get better and better as we combine them together. And that doesn't necessarily mean that the ML angle is the only part of it that is improving. I mean, a lot of it is just harnessing the data and getting all the data together and processed in such a way that we can leverage it. But these consumer apps will continue to get better and better. And having a simple UI, I mean, that's the ultimate goal of any usability designer, is to really make it as simple as possible, even though there's so much power under the hood. There's so much complexity there. So that's really the goal. So that space has tons of opportunity.
And let's kind of touch on the algorithms as part of that too. We haven't spent time really kind of talking about the algorithms, but I have to believe that that's part of the reason why you're kind of tapping in, either via API or some other function, you're tapping into some of the expertise from some of these other orgs.
Yeah, and that's exactly it. Yeah.
Yeah. Sorry, so where do they come in? The algorithms.
So the algorithms themselves come into operating on the data. And that's really about training up your machine learning models. So the algorithms are improving all the time. I mean, the amount of new papers that are coming out in the ML space, not just from the universities around the world, but even from the research departments of Microsoft or Apple, Facebook, Google. These algorithms are improving all the time, and they're actually getting them out there into the open source world, and that you can actually leverage them without having to understand all the nuances of those algorithms.
That's awesome. Let's we've got a couple other questions, but I want to come back to them in a minute. Let's jump to question number 6, because this is an area that I know you're really passionate about, and there are a lot of questions that come up. I get asked a lot of questions about this, but where does open source fit in with regards to machine learning? What is the role of open source?
Yeah, so that's a great question. So open source is really driving the innovation in machine learning. It's actually an amazing thing to see all these large organizations providing back their leading edge research that's coming out of their R&D departments and allowing the open source community to both continue to expand on it, make it available on other platforms and other languages, and allowing other machine learning enthusiasts to improve upon it, use it for competitions like Kaggle. I mean, the open source movement has sort of won. Like, everybody knows that that's the space you should be in. Almost all organizations are using open source in some form or another. And when it comes to machine learning, that is where all the innovation is happening. That's where all the action is.
But is open source the end-all be-all? I mean, so let me kind of put a little bit of context around this. I meet people and have conversations where the belief is everything is about open source. It's open source or open source or open source or open source. God, I can't even say that 3 times fast, let alone 10. Where open source is the end-all be-all. And then I talk to folks that commercial software and custom software is the end-all be-all. Are these extremes really the case, or is it a case where a more moderated approach of trying to tie in open source in certain ways and tie in commercial or custom in certain ways is the more likely approach? What is it? What's your take on that?
Yeah, there's no question it's a balance. So a lot of these proprietary solutions that you get, they're leveraging open source in order to actually provide their solutions, or they're creating their own. It really comes down to the value that's being provided. I mean, open source isn't the be-all, end-all. It's just in the machine learning space in particular, it is really driving the bus. Like, it's just there's just so much that's going on there, but it's never going to be the only part of it. I mean, you can get off-the-shelf solutions that provide algorithmic implementations already with data sets. Some of them are with pre-trained models, and for some organizations that is going to be a great solution, and for other organizations they're really going to want to dive in and have their teams build stuff on top of, let's say, Python or Go.
Interesting, very interesting. And this kind of is a nice segue into our last question, and this is kind of the kicker question, and before we go to that, I want to kind of preface it, but then the other piece that I think about is, some of the questions in the Q&A that I want to get to that folks have submitted kind of tie into some of these themes, and I think it'll be real interesting to get your thoughts on those. Let's go to this last question, question number 7. When you're thinking about ML, are there other factors that come into play, right? DevOps is a huge, huge movement and something that companies are leveraging in very successful ways. But then there are these other factors that have nothing to do with technology but have an incredible impact with technology, and that is the organization, the process, and the culture. So I want to talk about those pieces for a minute, because I think, as folks start to think about ML and think about new methodologies, I always find that organization, process, and culture inform a lot of the direction that things go. But I wanted to get your take on that, and then also where DevOps fits into this.
Sure, absolutely. So when we're talking about leveraging machine learning in your organization, we're really talking about adding new capabilities. So anytime you're adding new capabilities inside your company, you're basically saying there's a new team, there's a new set of people, and there's a new set of processes that have to occur. So like any change, it's not easy. So it needs to be well planned, it needs to have proper executive buy-in and sponsorship, and then all of the pieces need to work together. And that's really where we talk about DevOps, right? It was getting the development and the operations folks to work together as best as possible. And a similar thing is occurring in data science. When you add a data science capability to your organization, you're really saying, I need the data engineers, I need the data scientists, I need the developers and the ops people to all work together to give us a great solution. So a lot of the challenges we ran into with DevOps, we have to be aware of the same thing when it comes to adding these data science capabilities to our overall organization.
That's a great insight. Do you feel that ML is getting easier or harder for the masses to start to leverage? Kind of a bonus question I'm going to throw in there.
Yeah, so I think there's really been a democratization of access to all of this technology, and a lot of that is driven by open source. So I think it's actually getting easier over time. The tools are getting better. You're getting higher level tools. For instance, an example in Python is Keras. So you don't have to do near as much of this low level, build up a neural network, all this stuff. You can actually specify, okay, I want so many hidden layers. I want the inputs to look like this. I can swap other libraries in and out underneath, like a TensorFlow or a Theano. So the libraries are getting there, the tooling is getting there, and it's really coming to the point where we can get people that don't have to be hardcore data scientists and they can actually implement it. Now, I'm not suggesting that organizations do this without proper expertise on board, because there is some nuances in getting these solutions right, but there's no question that the democratization of all these tools is a huge help to the industry.
Yeah, I'm seeing something very similar, and this goes back to something I kind of started the conversation with, which is I'm seeing the rate of maturity in this space accelerate significantly, and that democratization is a key piece of it, but it's also lowering the hurdle. So you don't necessarily need to have that data scientist to be able to do this. It's not a minimum cost of entry, if you will. It used to be that if you didn't have a data scientist, don't even think about ML.
Yeah.
And it doesn't seem like that's the case at all anymore. So I want to get to, we've got a number of questions, and these questions are great questions, and I think they apply broadly to the space and to a number of different industries and perspectives. So let me just kind of dive into the questions that we've gotten so far. First, thank you for sharing the knowledge and time. Got kind of a philosophical question. Will eventually ML help towards humanizing data or putting data into human behavior? And I think this is a really valid question for all of these different ML projects that I touch and hear about, is that human component. I mean, what are you seeing? What are your thoughts here, Jeff?
Yeah, so this is a really interesting space, because when you're talking about machine learning, you're talking about the outputs of that being based on the inputs, and then the algorithm just learns it from there. So, you might say, well, that's obvious, but what isn't obvious is what is actually in that data. So I'll give you an example. What if you're doing image recognition of individuals, but all of those individuals are of a particular race? Then that means you're going to end up with a data set that does very well for one set of people, but very poorly for another set of people. There's also data around voice recognition. So if all you do is work on a data sets that are good for maybe English speakers with a particular accent, then the output of your model is going to be very good for one set and not for another. So I guess what I'm trying to get to here is it's important that we recognize you have to have a broad data set in order to make it human. Because what you don't want, sorry, go ahead.
No, go ahead, finish your thought.
What we don't want is all these biased algorithms. And so just like we can have biased rules that we write into applications, we can have biased data that goes into our machine learning. So there was actually a book recently published called The Weapons of Math Destruction, which I'm blanking on the author, but it's really about how biases are being built into a lot of these models.
Yeah, so that's a great point. So let me kind of get through some of these questions in the few minutes we have. There was a question around asking about the transcript of the webinar, and while we don't do a transcript per se, I'm sure, Jeff, you and the team would be happy to follow up with folks that will recap the links and you know, maybe provide a little bit of insight for folks that we've kind of touched on. That sound right?
Absolutely. Yeah, we'll put something together here because there's definitely some really important links that I think people could use that come out of this webinar.
Excellent. Okay, next question has to do with OCR. You know, I know this is a real big question, and there's a lot of detail on the question, but let me kind of summarize it a little bit. You know, OCR and text analysis, and when you start to think about, are there open source tools? Are there tools that will help you do OCR more accurately? And specifically, if you're having to deal with maybe technical jargon, maybe, and I see this, for example, in the healthcare space, right? You have medical terms that come into play. Have you seen any tools or advice you could offer around this area? You
know, for OCR, I'm not sure, but what the interesting part of that question is that it sounds like it's really getting a data set that's large enough that's specific to their issue. There might be a way to do this with adversarial networks where you're actually creating the data and then you've got another part of the network that is trying to decide how accurate it is and whether or not it's gosh, sorry, anyway, if you look up GANs, for instance, in machine learning, these are generative adversarial networks. That might be something that could help, but again, I don't know the OCR space that well, so.
Okay, fair enough. What is the role of messaging middleware in this space? And this is, I think this also speaks to a real question around where machine learning and integration, right? Because machine learning doesn't just sit in a vacuum,
yes.
Right? So what about that?
So great question. So again, depending upon the problem you're trying to solve, so messaging middleware could be very important to your overall architecture for driving the data into your ML model. So even things like for messaging systems like a Kafka, if you want to store particular things, you know, there's a lot you could do with some of the TIBCO solutions, or even just building your own messaging layer. I mean, there's some great libraries. I know in the Go space and Python space in particular, there's some really good libraries for that. So it really comes down to the architecture you're trying to build. So by all means.
So, you know, I want to go back to something you mentioned earlier because this next question touches on it. And I think it's a real issue for the masses, which is when you have a really big company, you might have the liberty of having access to just phenomenal amounts of data. But arguably, I would argue that that's actually still a small amount of data in the big scheme of things. The question really comes back to when you're gathering data for smaller companies, that's tough because they don't necessarily have that natively. What advice can you give organizations that maybe don't have a large data set to begin with? How can they augment that? How can they leverage that?
Yeah, there's a few things you can do there. So there are a lot of open data sets out there that could be helpful to train up your models, even if you don't have as much data yourself. So yeah, and I totally get it in the B2B space. This can be an issue. So that's one way to go. Another way is to try and generate representative data yourself in an automated fashion and train it that way and see if you get some better results. But you know, at the end of the day, a lot of these algorithms, they must have a sizable sample set in order to make meaningful inferences.
And that's, you know, I want to underscore that because that's something I think a lot of organizations and a lot of teams that are starting down this path, they don't understand until they have some experience in working with ML is the size of your data set is critical. Little data sets don't result in positive outcomes. And that kind of gets to our next question, which is, are ML models always returning correct answers? How do we know they're wrong? I think it's a great question.
Yeah, that's a great question. So our VP of Engineering here, Tom Radcliffe, did a presentation on this actually at one of the Pi Data conferences. And the key to really figuring it out is, good statistics. Are you getting meaningful results out of it? To help verify that the algorithms you're using are robust. And really, it's expert knowledge. So you know your business best. You've got business experts that are there. Try and see, does it make sense, the outputs you're getting? And if you're not sure and it's worth a try, you know what? Do some experiments first and try and figure out if these values provide the insight you're looking for. So there's no substitute to good old human know-how.
Yep. And so that's a great point, and something that I've also seen is, I'd love to get your thoughts on this, is context matters when you're thinking about machine learning. This isn't just a data problem, but you need to understand the context to be successful in this.
Yeah, that is so true. So and this is one of these, like, I've got a hammer and everything's a nail. So the context is so important. The data set for the context is important. And then, just as the previous question, you've got to be able to verify with human knowledge.
Yeah. So let me kind of get to the next question. If we consider input, processing, output, can you give the taxonomy for things which form part of each of these stages and interesting from a control perspective?
Yeah, so that really leads us to kind of when we touched on the workflow. Let's see, a taxonomy. Oh boy, I mean, it really depends on the area you're working in. There's a lot of items there, but maybe we'll just run through the workflow once more, so you get an idea. So as far as the input goes, so we're really looking at all the areas you can collect data from. So whether that could be log files or forms or images or whatever's coming in, and then really the processing side, it's the cleaning the data, it's getting it into the point where you can extract the features for your machine learning model. And then after that, you get to the point where you can actually run the algorithms on top of it. And then, obviously, that's the training part. And then you get to the point where you can deploy it inside of other applications. So that would be the output. And then, obviously, the interactions within the application or the APIs in order to provide the value. So that's really what we're looking at.
That training and retraining is key. And I think we've seen a couple of examples where it kind of goes back to the supervised learning comment, right? Where if it's unsupervised, the learning may go a little haywire.
Yes, absolutely, absolutely.
Well, we only have a couple minutes left, and so I want to use that time. I know we didn't get a chance to answer all the questions, but we'll follow up with you. Just a couple of key points here. Since we had the question about transcription, it sounds like we will go ahead and come back and find a way to address that. We're also going to respond to all the attendees with links to the book, to Andrew Ng's Coursera class that you could take a look at and follow up with you, because this is not the end of the conversation. This is really just the start. And so I would encourage you to engage, and let's keep the conversation going. So with that, I want to thank Jeff for taking the time and imparting your knowledge on all of us today and helping us understand a little more about machine learning and these different aspects. So thank you very much for taking the time.
Oh, it was my pleasure.
And it's always a great opportunity to mention, at Gigaom we have a lot of great resources, and I would encourage you to take a look at the site. Go back to ActiveState as well and take a look at what ActiveState has to offer. Great company, great people, great technology, great solutions. And so hopefully this will be just the start of the conversation as you kind of go down your ML journey. So thank you again. Thank you to the attendees, and hope everyone has a great rest of your day. Thanks for joining.
Thanks, everyone.